Okay, hello. Nice to see still so many people here, even it's very late afternoon. So I'm talking here, I'm Pekka Natri from Outotec. In the program there was mentioned Pia Subio, but she's not available, she's in Peru. So I came here instead of her. So I'm going to talk a little bit new demands of water treatment in mining industry. So in the presentation we will go through first some trends, general trends in mining industry and optimization of water balance. Then we look at an example of impurities which are accumulating to water systems, and especially we look at sulfate. We look a little bit what is effect of sulfate to the core process itself and what kind of problems it might make for equipments. And also we look shortly about environmental points there. After that we look through treatment methods, including Outotec ethylene process. So most of mining megatrends in the world, they are somehow related to the water. For example, ore grades are declining. This means that more water is needed to make a processing of the ore, which means that there will be more wastewater to be treated. Also, solid waste is increasing. It means that new tailings treatment methods are required. All the time, more complex ore bodies are being developed, and this means that more and more difficult wastewaters are generated, so new technologies are needed. Then, big part of mining industry is operating in water-stressed areas, and this is giving big reason to recirculate the water. And when you are recirculating water, you are accumulating impurities to the water circuit, and you need to have special kind of treatment for that, or then you need to bleed some water out from the process. If we look this typical water balance, here you can see raw water which is coming in. We first need to understand what kind of water we are taking. After that we have a processing plant itself, and here we have possibility to recirculate some of the water back to the process. And this is something where Outotec is very strong. We understand these processes. We know what kind of water can be recirculated and to which point of the process we can put it. Then in most of the cases, some of the water need to be bleeded out. And this bleed need to be treated according environmental permit. And you need to have special kind of process for that. When we look this whole water balance, it's important to remember when we are closing the water circuit, it means that we are also accumulating impurities to the water circuit. And when we are closing too much, it means that we are meeting a level where impurities are so high that they are really starting to have negative effect to the core process itself. Then we need to make a treatment for circulated water, or then open this water circuit a little bit more. If we think Outotec and water, it's good to remember that water usage can be optimized only if you really know core process itself. Outotec really knows mineral processing. That's the core of Outotec. And we know our customers' processes and we know water, so we can really make this whole water balance optimization. Each mine is having a different site-specific factors. Outotec has been delivering globally to all the continents, and we know different kind of requirements, including local legislation. Also, different type of minerals, they have different type of needs for water. Outotec is working with all the metals and minerals, and we really know what kind of water is required for each process. If we look one example, sulfate. Earlier days, sulfate was typically removed with lime precipitation. With that system, you can meet about 1,800, 1,600 ppm level of sulfate. But that is not enough nowadays, because most of the mining industry, it's located in somehow water-stressed areas, so more and more recirculation is done. It means that you need to clean the water there. Also, environmental permits are getting tighter and tighter, and water is really getting key strategic issue in the mining industry. Sulfate is harmful for process itself. It can decrease yield of the metals in flotation. It's also harmful because it can make a scaling and corrosion. And of course, environmental laws, they are getting tighter and tighter nowadays, so you need to meet them, and with the old lime precipitation system, you cannot meet these levels. So to reuse a sulfate-containing water, there need to be some kind of kidney treatment, or then you need to bleed some water out from the process and take fresh water in. Otherwise, you will lose your core process performance, or then you are creating a scaling problem to the equipment. In Outotec, we have done some studies what is the effect of sulfate to different flotation processes. And here, for example, with zinc, you can see that already after 400 ppm or 300 ppm, there is a big drop in zinc grade in flotation. And this is something where you can lose a lot of money. Same is happening with the gold flotation. Already after 150 ppm, we can see a drop in gold recovery. So this is really a question of money. In copper, this effect happens later on, so we need to go quite high, more than 5,000 ppm before this yield recovery and grade are dropping down. But there is another factor as well, and that is a scaling and corrosion. This is fully theoretical calculation where we assume that sulfate content is 3,000 and calcium is 1,300. Diameter of pipe is 0.5 meter and flow is 1 cubic in second. Here we have calculated how quickly we are getting whole pipe blocked. This 100% means that pipe is totally blocked. So less than 1 year you will have pipe totally blocked if you do nothing. What you can do is this kind of water treatment, kidney treatment, where you are removing sulfate, or then you can use antiscalants or something else. But you need to do something, otherwise you will meet this kind of nice pipes, and that is what no one wants to have. Then there is this environmental aspect. So this sulfate permits are getting tighter. In most of European community, they are getting nowadays, when new environmental permits are coming, it's 1,000 or below. Canada, it's 1,500. Chile, there are different levels. In whole South America, there is going to be a new ECA 3 environmental permit valid after 2 years, and sulfate levels are really low there. It's something like below 500. Then, of course, there are specific areas like Minnesota, so-called wild rice area, where sulfate level is only 10 ppm. So it needs to be very clean. It's good to remember that for drinking water, sulfate levels are about 250 ppm. So in some places, this is even lower than drinking water quality required. So how to remove sulfate? There are different ways to do it. One is biological sulfate reduction, which is working in certain kind of atmospheres very well. But in mining industry, where we don't have any organic compounds in the water, this is a little bit difficult. We need to add some methanol or something to keep bacteria alive, and that will increase operational cost a lot. Then there is membrane technology that is creating or making very good water quality, but it's also making this reject, which need to be treated. So it really doesn't remove sulfate from the water, it only concentrates it. And this reject need to be then evaporated, or then it need to be put into separate pond or something. Same with ion exchange. There is coming this backwashing liquid which need to be treated separately. Then there are these chemical precipitation methods, this old traditional lime precipitation, which is creating a gypsum. With that you can get somewhere below 2,000, depending on how much impurities there are in the water. But that's not enough for new legislations we have. Then there is a barium precipitation of sulfate. Barium is very expensive, so it requires some regeneration process, which increase the cost a lot. And also barium makes some environmental concerns. Then in Outotec we have developed this kind of nice ettringate process, which can really make low sulfate levels in the water. So what is ettringate? Ettringate is this kind of salt having a lot of calcium sulfate and a lot of crystal water. And it's naturally, when you see it in nature, it's a little bit yellowish. It's this needle type of crystal. Why to select this ettringate? Main reason is here. Solubility of ettringate is very low. So it means that you can create stable crystals. So then after precipitation you can easily separate them out and store them safely in a deposit. Also, amount of sulfate is reasonably high in this complex. So how this is working, this ettringate? First we have a water where are different kind of impurities. Then we send this water to the reactor where we are adding lime milk and alumina chemicals. And we are precipitating metals and sulfate and gypsum. And those are removed by solid-liquid separation. We cannot remove some like sodium, calcium, chloride, these components. But all the metals and sulfates, they are removed. Idea here is that first we have precipitation with a lime. We are removing this bulk of sulfate with lime precipitation because lime is cheaper reagents than alumina compound. So we are coming down to solubility level of gypsum, and after that we are continuing with alumina chemical down to decided level. With this ettringate precipitation we can go down to 0 if it is required. This level can be easily adjusted according to customers' needs. It can be even fine-tuned during an operations. Process itself, it looks like this. We have first, as I explained, this gypsum precipitation where we are removing most of the gypsum, most of the sulfate, and then we are separating it as a gypsum. And this can be sent back to the pond or it depends on plant. Then we have overflow of thickener. It goes to ettringate precipitation where we are adding alumina compound. It can be sodium aluminate or something else. We have also designed on-site preparation system for this. And we are feeding it to the reactor together with the lime. And ettringate precipitation is taking place. Then we are separating ettringate separately, and overflow, it's clean water. But it's having quite a high pH. There is a pH 12 required for this ettringate precipitation. That's why we are still making here CO2 neutralization. So we make carbonation. There is some calcium left in the liquid, and we are removing it here, and then finally we are getting treated water. So this is quite a simple, robust solution. It can be easily adjusted according to process requirements. Operational cost you can see here. We need to remember that cost need to be evaluated case by case, because most of the costs they are coming from alumina compound, and it depends what is the market price of this alumina compound. These costs they have been calculated according to Central Europe cost level. Here you can see delta sulfate, so it means how much sulfate you remove. For example, if we start from gypsum solubility level, which is about 1600, and we want to go below 1000, it means that we need to remove 600 ppm sulfate. Then operational cost is about 60 euro cents per cubic. So ettringate is good also for greenfields. So we are working for several projects where customer has existing lime neutralization, and new legislation is requiring lower levels of gypsum. So we are adding this additional step where is this ettringate process, and on that way we can reach these required levels of sulfate in bleed. So we can say process is flexible, customer can easily adjust it according needs. It can be started up and shut down very easily. It's efficient process if you have right kind of design of reactors and thickeners. Efficient means that we are really using very well all the reagents, and OPEX is very low. Then this is sustainable because it doesn't create any hazardous components, and also these precipitates like calcium carbonate and ettringate, they can be reused. So we can optimize your existing process or develop a new one, so you can save water and money. So you still have some time to visit our store. Please come and join. Thanks.